But what happens if the server is down? So if the server that proxy gets that didn't work. And what's worse, we just crashed the proxy. But we can fix that. We just have to listen for errors. We listen for errors, and then we're just going to print out the error, and then kill the string, so it sends back a sensible thing. We could also just go. We could also just go here. And then that still gets an empty message. And this tells us there was an equal introduced for our logs, but it continues to function. And when the server comes back up, we're back in business. Okay, so now let's build something a bit more interesting. So at this point we're called Scuttlebutt, which is if anyone's used if anyone's used Backbone or something like that, you have like a model object, and then you can go set and then a key and a value. Pretty simple, and that's change event. Well, this Scuttlebutt it's like that, except it is for except that you can connect multiple Scuttlebutt instances together with strings, and then whenever one gets an update, it sends a message to the other one, tells it to update as well, and then you can connect multiple of ones of these together, and then update them, and they will share the data between themselves. So there's two parts. This is the part where from the standard input, we're going to split it into lines, and then we're going to pipe it through, into setting messages. And then when it emits a message, we're going to write that to the output. And then this has two modes. If you run it as a server, it will create a TCP server. And pipe that into attach one end to the Scuttlebutt, and if you connect to a server, if you put it in client mode, then it connects to the host. It will connect to hopefully to the server, and then that will connect it to its instance of the Scuttlebutt. So we'll have one of each end. So if anyone checks that project out and sort it, now is the time to fire it up. And then you want to connect to that IP address. So the subset here. Oh, you've got to pass in a name. Okay, you're also going to have to make this quick hotfix. Which we just split. Oh, there's the server. And then make a client. And then connect to this. Here we go. Hang on. Sorry. Just the light debugging. And it works. Okay, so you can type messages first and send it to the server. Now, I'm getting suspicious. I think someone's sending me invalid data. Yeah, this guy's criminal. Yeah. So, okay, you okay? There we go. So now the server is robust to this. We'll just log his IP address so we can know to do things now. But if he connects with the correct protocol, then he'll be able to send messages. And one of the interesting things about Scotland is if, there we go. Now it's pretty nice. So notice he sent all these messages, some of them valid, while this client was underconnected. But the client can reconnect and the server will resend all of the missing messages. Can I connect to you? And that will update. And if I disconnect the server, oh, that'll make the client start. But what if because invalid messages, so all sorts of things can be happening in a real life environment. Servers can be going up and down, and so on and so on. You need to be able to handle unexpected situations. So what we really want is we want the clients to reconnect to the server. So here's like a very simple approach of how we want to do that. So when message comes in, so the message comes in, here on the client side, we will call connect, and then if the stream closes, we'll wait a second and then try and connect again. Pretty simple. So if you run 9, and 9 is client. Then if the server closes, it will tell us the server is down, and the server comes back up. It will reconnect. And that's really just a simple matter of waiting in a timeout. In theory, it's just simple matter. But in reality, in production, you don't really want your clients just waiting like 1 second and reconnecting again, because then you get a problem. I read about in a Netflix blog post where they really don't want to have outage, because if they have a problem, everyone starts pressing F5, and then so TCP has this interesting thing. So it has this thing called back pressure. So if the connection, if it's dropping back, if it's going slow, then it slows down and everything cooperatively reduces the amount of data it's sending, so that the end result can handle that. But there's nothing to handle the initial connection. So there's nothing to make the initial connection slow down. So once people start pressing F5, that's just like, actually what it's exactly like is, imagine you phone someone and they're in a really busy office and you can hear them talking on all these other phones and this sort of stuff. You're going to slow down and speak more clearly, and you're going to hear that they're going to mishear some of the things you say. But you don't know that when you call them. So if lots of people are calling them, they don't know that there's also calling them until they'll end this actual pick up the phone. And you get the same problem. So what you really want to do here is you don't want to program the clients to just call you again and again and again. You want them to program them to call you back when you miss connection, but it still must then call back again later. So each time you call back, like double the amount of time, double the length of time before you call back the next time. And you notice on Gmail, when the Wi-Fi goes down or something like this, and it says disconnected, reconnecting in such and such amount of time, and then each time it fails to connect, that time gets larger. That's what you should do. Okay, that's all I have for you today. Any questions?